Hello again, and welcome to the Science Workshop. Today we've got a little project about indicators solutions. And there are synthetic indicators and natural indicators, and this one is going to be a natural indicator. And we'll talk more about what it's indicating later, but basically it's going to tell you how acidic or basic that a certain liquid is. Okay, certain liquids are acidy and others are basy. And with this indicator, we'll be able to tell just by the color. Right? So the one we're going to use is purple cabbage. You get yourself some purple cabbage and you boil it up a little bit. And I just boiled ours in this little pot. I don't know if you can see, but there's a whole bunch of the cabbage and just a little bit of water, teeny tiny bit of water, and you cut it up like little shreds like that, and then just stir it around and boil it just a few minutes. It boils. If you are not an adult, you should get an adult before you boil something and chop things up with a knife. And then what you've got is this sort of juice that came out of the cabbage, and it's brilliant, beautiful blue color, which is a little weird already because the cabbage was purple, but the juice that comes out of it is blue. So that's kind of interesting, but that's our indicator. All right, so now we can use that to put into any fluid we want, any liquid, and we'll check out what the color turns to, and that'll tell us something about the liquid. Right, so I've got a bunch of things here. Some of them are not liquids, like this is baking soda. I'm going to put the baking soda in this little cup, little vasito, not too much. I mean, you put as much as you want, but it doesn't need that much. And then I'm going to put some water in on top of it, right? So there's that. And then I am going to put soap in the next one. You can put any kind of soap you want. I got like laundry soap here. Wow, that was a little too much. Dump that out again. Oh, you gotta put out that much soap. And you want stuff that's kind of clear. So this is not ideal because it's a little bit blue already, but you could use dish soap or laundry powder if you want, and have it sort of clear so the color of this doesn't mix up with the color of that. Then here I have some alcohol, rubbing alcohol, and I want to pour that in there as much as you want. I was going to pour this one full up to the top. Okay, that's the soap. And then I've also got salt. Put some salt right here in the middle. And pour it in there. Now I've got some milk. Milk is going to be white, but I think I'm going to put some water so it's not as white. Gonna like dilute it down a little bit so we can see the color come out better. And then over here we got the lemon. Squeeze the lemons. There's a lot of juice in there. Nice and acidy. Well, that's what, I mean, think about it. Acids are often sour. So if you have something that you've eaten that's really sour, it's probably acidic. Okay, so that's why we got the lemon here. We'll see what happens when we put it in acid. And then vinegar is also sour, super sour, and that's what I got here. Is the vinegar. Any kind of vinegar can work. All right, to add the indicator, you just squeeze some out and squirt it into the little cup. So there it is. We got that color. It's not so different from the color of the indicator. All right, now I have some in the blue one here. It's the soap. It's about the same color. That's interesting. I'll put one in the alcohol. Whoa, there we got a different color. It's kind of shocking. Now here's one for the salt. Well, it's turning about the same color. Now we got the milk. Find out what the milk does. Oh, it's got a little bit of purplish to it. The white is kind of masking it, but it's got that same purple. And now here's the lemon juice. Whoa! Unbelievable. Way different color. And the vinegar. Looks like it's even redder, even pinker. Well, there's all the colors. So the vinegar and the lemon were acid, super acidic. We know those are acids. Milk is also supposed to be acid. It's got an acid called lactic acid, but it's not a very strong acid. So maybe a less strong acid turns that color. That would mean the alcohol is also a low-level acid. But then the salt is neither acidic nor basic. It's kind of a neutral. So I would have expected the salt to be the same, about the same color as the original indicator. And then these two, the soap and the soda, those are basic, and the soda is supposed to be a strong base. So it could be that this cabbage that I've got right here does not indicate bases. It doesn't matter how much base you put in there, it just stays purple, stays blue like that. Yeah. And these natural indicators, they're all a little bit different. You can do this with any kind of fruit or vegetable that's got a color. It's like purple or blue or orange or yellow. You can try to use it as an indicator, using that same technique of boiling it and then getting the juice and then putting it in something. And then you can try any other substance that you can think of. Think of sour things. There's a bunch of candies that you eat that are sour. There's also tamarindo, and there's oranges and other citrus fruits. You can see the level of their acidity by the color that they turn. And then in terms of base, any kind of soap that you use, bases are often slippery, a little bit slippery. And so any kind of soap, laundry soap, dish soap, hand soap, you can try that. And then the baking soda is one of the really strong ones. There's also baking powder. You get baking powder from your kitchen. You can try that. All right, so the science behind the acids and bases is the science of solutions. This is called a solution. When the salt was in the cup, before I put the water, it was a solid. And then I put the water in there and it's like it disappeared. But it didn't disappear, it went into the solution with the water. So the pieces of salt are floating around there in the middle of the water, and there's disassociated. The salt is made from two things. It's made from sodium and chlorine. And once it gets into the water, those two things fall apart. Still salt, but they're floating around separately. And then how they act in the water determines whether it's a base or an acid. So the ones going from the lemon and the vinegar, they fall apart and they have a certain characteristic that makes it more sour and more acidic. And the ones from the base, they do the same thing. This baking soda is sodium and carbonate, carbon and oxygen. So that's sodium bicarbonate. And so when it hits the water, you got the sodium coming out and the carbon and the oxygen are all swimming around in there. And so you get a different characteristic of that mixture, that solution. All right, and so scientists have other ways to indicate exactly what the level of acidity or base is, but this is also a way to do it. And some experiments that scientists do, they use an indicator, and then they'll take a little dropper and they'll add, not the indicator, but they'll add something else. So watch this. I'm going to dump this one out into my cup here. So now there's just a little bit there, and I'm going to dump this base into the acid, one squirter at a time. Okay, and at some point, it's turning more and more base now. You see how the color is changing? It's also fizzing. Often when you put an acid and a base together, they fizz. But you see how the color changed. And if I keep going, the color will change all the way to something completely different. So the color is depending on the acidity. So some mixtures, it's a very sharp mark. Put like one more drop of the base into the acid and the whole thing changes color. That's called titration in chemistry. The chemists have this setup where they're dripping it in drop by drop, and the minute that it turns color, they know that they have reached neutrality, or it went from an acid to a base. So you may think that you're just playing around with the interesting little things in the kitchen, but you're actually doing real chemistry when you do this project. All right, so you can check out anything else you could get. You could get soda or other kinds of juice, anything that's a little bit clear, you could try it. Oh, I forgot to say that you could stir them up, the ones that are made with solids like salt or the baking soda, you can stir it up, but you don't want, I just did it, but you don't want to mix them one from the next one. So you're gonna get like little toothpicks, so each one mixes separately. And then you can mix them together and see if you can get all different colors. All right, have a good time. Oh, and in terms of safety, there's not that much safety here. Certainly with the knife and the stove, you want to be as careful as possible. Have an adult there. And this stuff, you just don't want to get it in your eye, basically. Don't drip lemon juice in your eye. You're gonna hate it if you do that, right? All right,